quick introduction from my side about ETH-Zürich. So before doing that, a big thank you to Manolo for making all of this happening. I think it's a great team and a great project that we are tackling here. From our side, there's like these main people that are involved. So Henrik Kolmdach is postdoc in my group and a specialist for terrain classification. Then we have Lorenz Wellhausen, already senior PhD student working on navigation and path planning, myself, and then of course quadrupedal systems. These ones still having stupid feet, but hopefully by the end of the project, that's going to be a lot more intelligent. It's not only the participant. I think that is important also to know for this consortium. There's a big team behind that, which has extensive knowledge from designing of robotic systems over control and autonomy to field deployment of them. So we are participating in many different field relevant or application relevant scenarios, and all these people are involved in that. Before diving into the specifics that are relevant for NI, a very brief overview about the research in general that we are tackling in our group. As I mentioned, focus is on locomotion and manipulation, and in particular in uncertain and unstructured environments. So we're designing new actuators and robots. We're working a lot on model-based planning and control for these hybrid systems, so systems that are in contact with the environment partially. Working a lot in reinforcement learning, then multimodal perception, including also haptic interact with the environment for classification and traversability estimation in order to make the systems being able to navigate in unstructured environment, and work on state estimation, model estimation, which is not so relevant for this European project, and then on haptic interaction and operation. So you see here a bunch of platforms that most of them developed from scratch in our group. This is legged robots, mobile manipulator systems, but also large-scale construction machines that we're using for construction automations and things like that. Now, the most relevant for NI is animal, and I want to briefly dive into this, just a few minutes. So this research that has, in the meanwhile, more than 10 years of a history, so something that we started at the research lab, developing first prototypes that could like walk under laboratory conditions over research machines that we use for field deployments, to today field-ready quadrupeds that are commercialized through our spin-off Anybotics, where there's more than 50 people in the meanwhile, distributing them primarily for industrial applications, but then also through partners like us, partners like you, partners like PISA, for new applications like natural inspections and things like that. I would like to give you here a very specific or a very special introduction to all of that, which is a little more in the spirit of what NI is. I hope you can all hear the sound playing now from the video.
The animal. To the untrained eye, it may look like a robot, and that's because it is. But it's no ordinary robot, it's an animal. This animal has just enjoyed an underwater excursion, because it can. The animal is the only robot of its species to be completely waterproof. For robots in Switzerland, it's regeneration season. Animals use 3D lasers to scan its environment for the perfect place to rest. Most species hibernate for the entire season. Animals complete their battery cycle in only 3 hours. Now that our animal has had its power nap, it's ready to go back to doing whatever its programmer tells it to. Comfortable in any habitat, the animal can go anywhere. Anybody.
Okay, so this gives you a little bit of an impression of, in the spirit of NI, brief introduction, because this platform might be used by several team members here in the context of NI, what the platform is about. So what it has is LiDAR sensors on top that we can like 3D perceive the environment. Then we have 4 wide-angle cameras, 4 stereo cameras around to do terrain mapping. We have wide-angle cameras in the front and in the back in order to like see what's going on in RGB image. Then for outdoor missions, also probably useful in NI, RTK, GPS. And last but not least, we can mount a pan-tilt inspection head where we have like optical zoom, thermal cameras, and light on it, which might be useful for some parts. Now we're using the platform in various different projects and applications. One side most relevant here is for flora monitoring in this natural intelligence EU project, but we also have collaborations with the Swiss Federal Institute for Flora, Snow and Landscape, where we do forestry mapping. As Manolo pointed out, we're using these machines on the ground for sewer and mine inspection. We're participating in a DARPA SAPTI challenge, where there's this robot is used to fully autonomously explore underground areas, search and rescue application, industrial maintenance works, and also some space applications. These following videos shall give you a little bit of insight in how all of that looks like. So we have on the top left video, we see how the robot fully autonomously explores a nuclear power plant in the US. And you can also see what the robot sees while going there around, how it maps the environment, how it can plan navigation path, how it perceives the underground and uses that for foothold planning. Then we have on the top right, we have a first project where we really used haptic information. So we use feet that are sensorized in order to classify the terrain. So these are primarily vibration measurements and force measurements that we use in order to identify the level of vibration and the level of deterioration that we have on the ground. And on the bottom 2 videos, these are classical industrial applications from industry inspection surveying over construction monitoring and things like that. Now, the technology behind that, you're going to see more details tomorrow when we're looking at the different work packages. Just briefly, what we are working on. First aspect which is relevant for NI is reinforcement learning for locomotion control, where we essentially start in simulation to train complex locomotion behaviors to overcome all kinds of different grounds, and then generalize this in order to be able to walk over natural grounds. So you see here a number of different deployments where we also took the robot on a hike to the mountain, where we deployed it going through riverbeds, in forests and stuff like that. And this is the type of locomotion you want to see also in NI, that we have capable ground robots that can literally go where humans can go today in order to sample the environment. Now, in all of that, important to understand is that this is all human operated, in the sense that there is a person who has an understanding of how the environment look like and where the robot might be able to walk through and where not, and guides in the robot with joysticks. Of course, we want to automate this. So the second part of our contribution will primarily focus on local navigation planning. So given a perception of the environment and certain footholds, how can then the robot like go from A to B and plan that locally? All of this, what you see here, is purely geometry based at the moment. But of course, if you go to a natural environment where you have bushes and grass and vegetation, it's getting a lot more tricky. You have to better understand the environment and use that in your navigation planning. And then a third element, this is like high level autonomy, where it's about like exploration of larger space areas. What you see here is the robot going into a director building of SATSOP in the US. So this is a couple of 100 meters of distances that these robots can autonomously traverse, map the environment, and come back with a very detailed map of how the situation looks like. And then the last aspect which we're contributing here is how can we make systems that, even if they fall at some point, are able to get up and continue to operate again. Also, this demonstration that we did here initially was only done in lab environments, but of course we want to bring this to like most generic environments, that we have systems that can just continue to operate no matter what happens. And this brings me to the last one. So our main involvement is in work package 4 on high-level autonomy for unpredictable environments. I want to see all of these skills that I just showed you before in environments as we depicted here. With this, I'm closing.